help you? Yes. I'm Allison Seinstack.
But I'm Limitless Luke.
You know, that is such a terrible name.
You know what? Don't throw a tangent.
I won't. Anyways, on to the more important breaking news. So, we have sports coming your way.
Alright, so I'm standing here with Joe Girardi, Yankees manager. He shows no emotion, ever, just because. But right now, we're at the Yankees game. Yankees are down, but they have runners in scoring position. Here comes the pitch. Let's see if we can get a hit. And to infinity and beyond! Speaking of infinity, that reminds me of the ratio test, which states the limit of n as n approaches infinity is the absolute value of a sub n plus 1 over a sub n. Now let's see what he did. Did he? Yeah, he got runs. That's what I'm talking about. Go Yankees. Boo Red Sox. Alright.
Wow. Thank you for that report. So, anyways, I just want to say, why was the parent function upset with the child function?
It was stretched to its limit.
Oh, it's such a good one every time. Alright, anyways, we're going to move on to traffic with Livy DeRibby.
Hi, I'm Livy DeRibby, and I'm here with velocity, acceleration, and speed. Why don't you guys tell me about yourselves?
Well, hi, I'm the first derivative.
Hi, I'm acceleration and I'm the second.
Anyways, when I'm positive, you go forwards, and when I'm negative, I go backwards. Anyways, when I'm increasing,
I'm positive.
she's positive, and when I'm decreasing,
I'm negative.
anyways, speed, brother,
When they're the same sign,
he increases,
and when they're different signs,
speed decreases.
yeah.
What else you want to say?
Well, I do have one thing I would like to say, and that's when, if you take the integral of me, you get how far you went, okay? But if you take the integral of the absolute value of me, that's the total distance I've traveled.
So, like, forward and backwards.
Yeah, absolute value, forward and backwards, total distance traveled. But without the absolute value signs, just the integral of me, that's how far I got.
Go.
Interesting.
Yeah.
Fascinating.
We'll be right back with Dr. Flurger.
But first, here's a word from our local sponsor.
Are you tired of your boring life? Do you just want to derive stuff? Doesn't that sound fun? How about you derive some products?
Yay!
I know how to do that.
Great, because I don't.
Well, this is how you do it. When you have a function, say big bowl times big spoon, and you want to take the derivative of it, you take big bowl times the derivative of big spoon, which is little spoon, and you add that to big spoon times the derivative of big bowl, which is little bowl. And that is the derivative of big spoon times big bowl.
That's fascinating.
Isn't it? And the cereal's not half bad either.
Hi, I am Dr. Flurger, and this is my assistant for the day. See how things work out. Jenny.
Hello?
Jenny.
Hello?
It's Jenny.
Hello?
I may at times call her Flat Dog. We'll see how things go. Jenny.
Hello?
So, here's our first problem. We have d over d of x, which is derivative
Derivative?
of
Is that Megan?
sine of x over x cubed.
X cubed, don't forget it!
That's our equation. We have to find the derivative of that. Now, what are we going to use? We're going to use the quotient rule.
The quotient rule!
The quotient rule states high, low, d high, minus high, d low, square below. Now that just simply means, when we do this, we would start out with x cubed
X cubed, don't forget it!
times the derivative of sine of x, which is cosine of x, minus sine of x times the derivative of x cubed, which is 3x squared, over, let me square below, x cubed squared is x to the 6. And that is how you use the quotient rule. Jenny.
Hello?
Don't drink and derive! Gosh! How many times I gotta tell you this? And now on to limits.
Aaron, what's a limit? You mean like a speed limit?
No, you silly.
The limit does not exist. The limit does not exist.
You can take the derivative.
No, you can't.
Yes, I can.
No, you can't.
Yes, I can.
No, you can't. It's not differentiable.
Ah, it's continuous.
You see that?
Alright.
He's tired.
This is nonsense!
So, like, do you record yourself just, like, solving math problems?
Yes, we're recording right now, actually.
That's so dumb.
Yeah,
Can't we just go, like, shopping?
no, we're gonna do this now. So, today we're gonna do some L'Hopital's rule.
Is that even American?
Yes. And American's not a language.
Yeah, it is. I'm speaking American.
You're speaking English. So, L'Hopital's rule. Say you have a question that is the limit of sine of x over x as x approaches 0. Now, you may think this equals undefined, because you would have 0 in the denominator, sine of 0. That would equal 0, right?
No.
And you can't have 0 in the denominator. So this is just wrong. You don't do that. What you actually do is L'Hopital's rule, like I said this lesson is. So you have this equation, and am I boring you?
Yeah, actually, like, when are we going shopping?
Third Sunday of tomorrow. So we have this. L'Hopital's rule is quite simple. You just take the derivative of the numerator and the denominator, and then you sub whatever your limit question is. So we would take the derivative of the numerator, which is cosine of x, and the derivative of your denominator, which is 1. And then you just plug in 0, because it's as x approaches 0. So when you do that, you would get cosine of 0 over 1, which equals 1. So then that means that the limit as x approaches 0 of sine of x over x equals
1.
Brittany, would you like to tell us the answer?
I'm gonna, like, say it's, like, 1.
Proud of you. That's right. Proud of you.
Can we go now?
Now, how did we get this answer? What did we use?
No.
What did we use?
The American rule.
Which is called?
The hospital. Right?
Nope. It's L'Hopital's rule.
That's what I said.
And that is how you use L'Hopital's rule.
We're ready? Let's go. For those of you who want to know about Calc, it's like this, y'all. 10% love, 20% skill, 15% differentiation at will, 5% series, 15% test, and 100% reason to remember calculus now. We're going to review the applications of different formulas of integration, the area between the curves, goes like this. Top minus bottom, take the integral is what it is. The same goes for terms of y, only right minus left, you don't need the pi. Dividing across sections is not complex. Take the integral of the error and you got the rest. Yep, 10% luck, 20% skill, 15% differentiation at will, 5% series, 15% test, and 100% reason to remember calculus. Now, for our blanks, don't forget it. We have Cartesian and parametric. Now, Cartesian, take the integral root of 1 plus the first squared. Don't forget the square root. Yeah, 10% luck, 20% skill, 15% differentiation at will, 5% series, 15% test, and 100% reason to remember calculus. And parametric, take the integral dude of x squared plus y squared, the square root. Now, area of a polar curve, don't laugh. Integral of r squared, you need to cut that in half. Yeah, 10% luck, 20% skill, 15% differentiation at will, 5% series, 15% test, and 100% reason to remember calculus. Last but not least, volumes of revolution. Don't worry, this is not a delusion. You have two methods, washer and disk. It's a little dangerous, but you can take the risk. For disk method, the integral r squared, multiply by pi, and don't be scared. Washer method is almost the same, only big R squared, little r squared instead of r, okay? 10% luck, 20% skill, 15% differentiation at will, 5% series, 15% test, and 100%
reason to remember our calculus.
Word.
Hi, I'm Dr. Flurger, and today we're going to do another installation of derivative rules. Now, I think you're wondering what happened to Jen A. Well, I fired her. She annoyed me. Next up, as my new assistant, is this other girl. What was your name?
My name is Peppa and I'm from India.
No, shut up.
Sorry.
Strike one. 3 strikes and you're out. Okay? So, stop trying. We're going to do the chain rule. Chain rule is quite simple. Say we have this equation. Say, f of x equals sine 3x. This is simple. Let's rewrite this. So we sine of 3x. You can easily see that you have an outer and... Peppa.
Sorry.
Strike 2. One more and you're out. So, you have an inner and outer function. Your inner function is 3x, and your outer function is sine. When you do the chain rule, you take the derivative of the outer function, so derivative of that would be cosine. You leave the inner function alone, so it would be cosine of 3x, and then you times all of that by the derivative of the inner function, which is just 3. So, the derivative of this function up here would be 3 cosine 3 of x. And that's a simple way to do chain rule. Now, hi, I am Dr. Flurger, and today we're going to do another installation of the derivative rules. This is a different type of rule. We're going to do implicit differentiation. And, oh wait, that's right, I did not introduce my new assistant. Annabelle.
Hi, y'all. My name's Annabelle, and I'm from South Carolina.
The new assistant.
I'm just so thrilled to be here.
I bet you are. I am quite the exciting fella.
I can tell.
I know, and I'm handsome. Look at me.
Yes, very.
Thank you. So, implicit differentiation. Quite simple. We're going to go with a pretty easy equation. We have x squared plus y squared equals 100.
Oh, my.
So, implicit differentiation, you just, you want to take the derivative of that. So,
In terms of y and x.
I was getting that. In respect to x. So, you do this. 2x plus 2y.
Oh my goodness gracious, that reminds me. The other day on the farm, my papa and I were out milking the cows one early Sunday morning, and I realized that we were missing 2 chickens and 2 pigs. So my father had to go out and chase them like the 4th of July, and it was a mess.
That has nothing to do with that.
Oh, sure it does. You got 2x and 2y, and I thought about 2 chickens and 2 pigs.
Well, that's different. Anyway, you have this, and since it's in respect to x, you also have to put in y primed. And then when you take the derivative of the other side, it's just any derivative of a constant is 0, because it's constant. So, you have 2x plus 2y, y primed equals 0. Now you want to get the y prime, which also equals dy dx. Okay. So, you have this. You want to get y prime alone. So, to do that, you would subtract both sides by 2x. So you have 2y, y primed, equals 2 of x. Negative 2x. 2 of x, sorry. And then you divide both sides by 2y, which would then give you negative 2x over 2y. And then that you can just simply cancel those out because they cancel out. So then you have y prime equals negative x over y. And that is how you do implicit differentiation.
Oh, that was just so exciting.
I am Dr. Flurger, and today we're going to do another installation of the derivative rules. This is a different type of rule. We're going to do implicit differentiation. And, oh wait, that's right. I did not introduce my new assistant. Annabelle.
Hi, y'all. My name's Annabelle, and I'm from South Carolina.
The new assistant.
I am just so thrilled to be here.
I bet you are. I am quite the exciting fella.
I can tell.
I know, and I'm handsome. Look at me.
Yeah, very.
Thank you. So, implicit differentiation.